December 17th, 1944. The frost-covered fields outside Stavelot, Belgium. Oberleutnant Klaus Hartmann crouched behind the turret of his Panther Ausführung G, binoculars pressed against his face. Through the morning fog, he could see them. A column of American Shermans, perhaps 8 or 9, moving along the tree line nearly 2,000 meters away. He lowered his binoculars and allowed himself a thin smile. They were too far, much too far. The American 75mm guns couldn't touch him at this distance. He'd seen it dozens of times before. Shermans firing, rounds bouncing harmlessly off Panther armor, and then the inevitable. His own long-barreled 7.5cm gun would speak, and another Ronson would light up. That's what the Germans called them now, after the American cigarette lighter advertisements. Lights the first time, every time. But this morning, something felt different. Hartmann noticed the Shermans weren't advancing recklessly as they usually did. They were taking positions, hull down behind the ridgeline, turrets traversing with deliberate precision, and their gun barrels. He squinted. They looked longer, thinner, not the stubby 75mm tubes he'd grown accustomed to seeing. Before he could process this observation, one of the Shermans fired. The crack echoed across the frozen field. Hartmann instinctively ducked, but immediately felt foolish. 2,000 meters, impossible range for a Sherman. Then he heard it, a sound like tearing metal. The Panther to his left, commanded by his friend Hauptmann Werner Steiner, suddenly lurched. Smoke poured from its engine deck. The crew bailed out, stumbling through the snow in disbelief. Hartmann's radio man shouted, "They hit Steiner. Direct penetration. How is that possible?" The question hung in the frozen air like the smoke now billowing from the destroyed Panther. For months, German tankers had operated with a fundamental certainty. The Panther was superior. Its sloped armor, its powerful gun, its tactical dominance over American armor. All of it was gospel. But in that single moment, watching his comrade's tank burn at a range that should have been absolutely safe, Klaus Hartmann felt that certainty crack like the ice beneath their tracks. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. What had just happened defied everything the Germans believed about American tank capabilities, and it was about to get worse. Because across that Belgian field, American tank crews were loading a new type of ammunition, a tungsten-cored round that would rewrite the rules of armored warfare and shatter German confidence in their most formidable weapon. This is the story of how a technological leap caught an entire army by surprise, and how the hunters became the hunted. By late 1944, the German Panther tank had earned a fearsome reputation. Its combat debut at Kursk in July 1943 had been troubled by mechanical failures, but by the time German forces faced the Allied invasion of France, the Panther had matured into a genuinely dangerous weapon. Its frontal armor, sloped at 55 degrees, could deflect most Allied anti-tank rounds. Its 7.5cm Quai 42L70 gun could destroy a Sherman at ranges exceeding 2,000 meters. German tank doctrine emphasized this standoff capability. Panther crews were trained to engage enemy armor from distances where return fire posed minimal threat. The mathematics were simple and brutal. A Panther could kill a Sherman at 2,000 meters. A Sherman with the standard 75mm gun could only penetrate Panther armor at ranges under 500 meters, and even then, only with side or rear shots. This 4-to-1 range advantage meant Panthers could systematically destroy American tank formations before the Shermans could even fight back. After-action reports from Normandy told the same devastating story. American tank battalions would advance, encounter Panthers at long range, and watch helplessly as their lead tanks erupted in flames. Crews described the psychological horror of knowing they were outmatched, knowing they had to close the distance under fire, knowing that for every 100 meters they advanced, more friends would die. One tanker from the 2nd Armored Division wrote home in September 1944, "We count ourselves lucky if we can get 3 Shermans close enough to flank a single Panther. Usually we lose 2 in the process. The math doesn't favor us, and the boys know it. Every time we roll out, we're wondering who won't make it back." The German tankers, meanwhile, had grown confident to the point of arrogance. They knew their advantage and exploited it ruthlessly. Panther commanders would position their tanks on ridge lines or at tree line edges, using their superior optics to acquire targets at extreme range. They would fire, observe the hit, and often withdraw before American artillery could respond. It was hunting, not combat, and the prey knew it. But in Detroit, Aberdeen, and Watertown Arsenal, American engineers were working desperately to close this capability gap. The problem was understood with brutal clarity. American tank guns needed more penetration, more velocity, more punch. The 76mm gun had been developed as a partial solution, offering better performance than the 75mm, but even with standard armor-piercing rounds, it still couldn't reliably penetrate Panther frontal armor beyond 800 meters. The answer lay in a rare element: tungsten. With a density nearly twice that of steel and a melting point exceeding 3,000 degrees Celsius, tungsten could maintain its shape and mass during the violent impact with armor plate. If engineers could design a projectile that combined tungsten's density with extreme velocity, they might finally give Sherman crews a fighting chance. The concept wasn't entirely new. The British had experimented with tungsten-cored ammunition earlier in the war, but American metallurgists at Watertown Arsenal refined the design into something revolutionary. The M93 hypervelocity armor, piercing round, or HVAP, consisted of a lightweight aluminum body surrounding a tungsten carbide core. The aluminum sabot fell away after leaving the barrel, leaving the dense tungsten penetrator to fly toward the target at speeds approaching 1,000 meters per second. The physics were elegant. Lower mass meant higher velocity from the same powder charge. Higher velocity meant more kinetic energy on impact. More energy concentrated in the dense tungsten core meant penetration that could punch through armor plates that would shrug off conventional rounds. In testing at Aberdeen Proving Ground in early 1944, the results exceeded even optimistic predictions. The M93 HVAP could penetrate 150 millimeters of armor plate at 1,000 meters. This wasn't just an improvement, it was transformative. A 76mm Sherman firing HVAP could now threaten Panther frontal armor at ranges the Germans considered absolutely safe. But there was a critical problem. Tungsten was desperately scarce. The United States had limited domestic tungsten deposits. Most came from imports, primarily from China, Portugal, and South American sources. Every ounce had to be carefully rationed between competing military needs. Tungsten was essential for machine tool cutting edges, for armor-piercing aircraft ammunition, for countless industrial applications. Tank ammunition competed with all of these demands, and there simply wasn't enough to go around. The Ordnance Department made a difficult decision. HVAP rounds would be issued in strictly limited quantities. Tank crews might receive 5 rounds per vehicle, sometimes fewer, sometimes none at all. They were to be used only against heavily armored targets when standard ammunition would be ineffective. Every round had to count because there were no reserves to waste. This scarcity meant German intelligence remained largely unaware of HVAP's existence through most of 1944. A handful of rounds captured here and there didn't reveal the full scope of American capability. German technical intelligence officers examined the unusual ammunition when they found it, noting the lightweight projectile and strange aluminum components. But without understanding the tungsten core's properties or the velocity it achieved, they couldn't appreciate the threat. The first HVAP rounds reached frontline American units in France during late summer 1944. Distribution was haphazard, prioritized for units most likely to encounter heavy German armor. Tank crews received minimal briefing. The ammunition was scarce and powerful. Use it wisely. Aim for center mass. Expect significant recoil. Some crews skeptically loaded the odd-looking rounds, wondering if this was just another promised miracle that would disappoint like so many others. Then they fired them in combat, and everything changed. A gunner from the 4th Armored Division recorded his experience in October 1944 near Metz. We'd been told the new shells could kill Panthers head-on. Nobody really believed it. We'd tried too many times before and watched our shots bounce. But my loader had one HVAP round, and when a Panther appeared at maybe 1,500 yards, the lieutenant said to use it. I centered the sight, fired, and the recoil nearly knocked me off the seat. The Panther just stopped. Smoke everywhere. I couldn't believe what I was seeing. Word spread through American armored units with the speed of hope long denied. The new ammunition worked. Shermans could kill Panthers at ranges that had previously meant certain death. Morale, which had been deteriorating as casualties mounted through the autumn fighting, suddenly recovered. Tank crews who had felt like sacrificial lambs now felt like they had a chance. But for the Germans, these early encounters were isolated and confusing. A Panther destroyed at long range by a Sherman. It must have been a lucky shot. A weak point hit, some ammunition malfunction. The idea that American guns could threaten Panthers frontally at 1,500 to 2,000 meters contradicted everything German doctrine assumed about enemy capabilities. Then came the Battle of the Bulge, Hitler's desperate winter offensive through the Ardennes, launched on December 16, 1944. Hundreds of Panther and Tiger tanks poured through the snowy forests, aiming to split the American and British armies and recapture the port of Antwerp. It was Germany's last major offensive operation in the West, and it would become the crucible where HVAP ammunition revealed its full potential to a shocked German Panzer Corps. As Panther columns advanced through the fog and snow, confident in their tactical and technical superiority, they began encountering resistance that defied all expectations. American Shermans that should have been easy prey were destroying Panthers at ranges that German commanders had considered absolutely safe. And it was about to get much, much worse. Now, inside those frozen forests where German tankers would face a truth that would shatter their confidence and change how they fought for the remainder of the war. The morning of December 19, 1944, brought chaos to the roads around Stavelot. Kampfgruppe Piper, the armored spearhead of the 1st SS Panzer Division, had been driving deep into American lines for 3 days. Their Panthers and Tigers had crushed resistance with the speed and violence that made German armor legendary. But now they were stalled, strung out along narrow roads, running low on fuel, and starting to encounter something unexpected. Organized, determined American resistance. Lieutenant Bill Mackenzie's Sherman from the 7th Armored Division's task force had taken position on a hillside overlooking the road to Stavelot. His tank, one of the newer Easy 8 models with the improved 76mm gun, had received just 4 HVAP rounds 2 days earlier. His gunner, Corporal Sam Dietrich, had test-fired exactly 0 of them. The crew had no idea what to expect beyond the brief instruction they'd received. High velocity, very powerful. Save them for the big cats. Through his periscope, Mackenzie watched 3 Panthers rolling down the road below. Range, approximately 1,800 meters. In normal circumstances, this would be a death sentence. The Panthers would eventually spot his position, and their superior guns would tear his Sherman apart long before he could close to effective range. But Mackenzie had those 4 special rounds, and for the first time in his 7 months of combat, he felt something other than dread when facing Panthers. Load, HVAP. Dietrich's hands moved to the unfamiliar ammunition. The round felt different, lighter than standard armor-piercing despite being the same length. The aluminum body gleamed dully in the cold light filtering through the turret. He slid it into the breech, feeling the mechanism close with its familiar metallic clunk. On the lead Panther. Mackenzie's voice was steady despite his pounding heart. Dietrich settled behind his sight, adjusting for the extreme range. The Panther was still moving, unaware of the Sherman watching from above. 1,800 meters. Everything he'd learned said this was impossible, but the brass had said these rounds could do it. Only one way to find out. Fire. The 76mm gun spoke. The recoil was noticeably sharper than with standard ammunition, the entire tank rocking back on its suspension. Through the smoke and the scope, Dietrich watched the tracer, streak toward the distant Panther. Time seemed to stretch. Then impact. The Panther jerked violently, as if struck by a giant invisible hammer. Smoke burst from every hatch and seam. The turret crew began bailing out immediately, scrambling away from their mortally wounded machine. Jesus Christ! We got him! Mackenzie's voice cracked with disbelief. At 1,800 meters, we actually got him. The other 2 Panthers had stopped, their commanders clearly confused. One of their number had just been destroyed by a Sherman at a range where Panthers held absolute superiority. It made no tactical sense. It violated everything they understood about American capabilities. The second Panther began traversing its turret, searching for the threat. Mackenzie didn't give them time to find it. Second round, same target set, fire. Another HVAP round screamed downrange. This shot hit lower, penetrating the side hull where the armor was thinner. The Panther erupted in flames as fuel and ammunition ignited. The third Panther, now thoroughly alarmed, began reversing rapidly back down the road, abandoning any pretense of maintaining the advance. Mackenzie's crew sat in stunned silence for a moment. They had just accomplished something that should have been impossible. 2 Panthers destroyed at extreme range by a Sherman that German doctrine said posed no threat at such distance. The psychological impact of this reversal would prove as devastating as the physical destruction. Within hours, reports began filtering through German command channels. Panthers destroyed at long range by American fire. Initially, commanders assumed these were anti-tank guns or tank destroyers, but frontline crews reported seeing Shermans, the distinctive profiles of M4 tanks, not the low-slung M18 Hellcats or towed anti-tank weapons. Shermans were killing Panthers at 1,800 to 2,000 meters. This was impossible. This couldn't be happening. Oberleutnant Klaus Hartmann, the Panther, a commander who had watched his friend's tank burn that morning, spent the afternoon in an increasingly desperate tactical situation. His company had lost 4 Panthers to long-range Sherman fire, 4 tanks destroyed before they could even identify their attackers with certainty. The American guns were firing from hull-down positions at extreme ranges, using exactly the tactics Germans had employed against them for months. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By nightfall on December 19th, Hartmann gathered with the surviving commanders of his battalion for a hasty conference in a snow-filled farmhouse. The mood was grim. Everyone had stories. Panthers hit frontally at incredible ranges, shots that penetrated armor that should have been proof against Sherman guns. Crews who had considered themselves invulnerable, now speaking in terms usually reserved for describing tiger operations. Stay dispersed. Don't present the front. Avoid long sight lines. Major Strasser, their battalion commander, had retrieved an unusual shell fragment from one of the destroyed Panthers. The base of an armor-piercing round, but oddly light, made of aluminum rather than steel. He passed it around the assembled officers in the lamplight. None of them had seen anything like it. This came from Brown's Panther, penetrated the glacis plate at an angle that should have caused deflection. Whatever the Americans are firing, it's new, and it's effective. The implications spread through the German panzer forces like frost creeping across glass. If Shermans could now threaten Panthers frontally at ranges exceeding 1,500 meters, the fundamental tactical calculus had shifted. German tanks could no longer rely on standoff engagement to ensure survival. They would have to close, maneuver, use terrain aggressively, all tactics that negated their technical advantages and exposed them to the superior numbers and coordination American forces could bring to bear. German tank crews had built their entire tactical doctrine around one unshakable assumption. Panthers could engage Shermans at ranges where American guns posed no threat. But by late December 1944, that assumption lay shattered across the frozen fields of Belgium. Intelligence officers at Panzer Group West headquarters received increasingly alarming reports. Panthers destroyed at extreme range. Frontal hits that should have been impossible. American ammunition that behaved unlike anything they'd encountered before. On December 22nd, a damaged Sherman from the 3rd Armored Division was captured intact near Mannheim. German ordnance specialists examining the wreckage found something extraordinary in the ammunition racks. 4 unfired rounds marked M93 HVAP-T. The projectiles looked wrong, too light. The bodies appeared to be aluminum rather than steel. When technicians weighed them, the discrepancy became obvious. These rounds massed significantly less than standard armor-piercing ammunition. Hauptmann Friedrich Weber, an ordnance officer with extensive ballistics training, supervised the examination. He recognized the design immediately. It was an armor-piercing composite rigid projectile, similar in concept to the German Hartkern munition tungsten rounds the Luftwaffe used in aircraft cannon. But this was scaled up dramatically for tank guns, and if the Americans were issuing this to Shermans, the implications were catastrophic. The M93 HVAP round achieved a muzzle velocity of approximately 3,400 feet per second DTIC, far exceeding the 2,600 feet per second of standard armor-piercing ammunition. This velocity translated into penetration performance that closed the capability gap between Sherman and Panther dramatically. At ranges under 1,000 meters, HVAP could penetrate over 150 millimeters of armor plate panzer war. Against Panther turret mantlets and side armor, This was more than adequate. But there was a critical limitation, German analysts soon identified. The lightweight HVAP projectile slowed faster than conventional ammunition, such that penetration dropped below standard rounds at ranges beyond 1,500 yards. Wikipedia. The tungsten core's lightweight and high initial velocity meant it bled energy rapidly. This made HVAP devastating at medium ranges, but less effective at extreme distance, where German tankers preferred to fight. Weber's report circulated through the Panzer Command within days. The conclusion was stark. American Shermans, armed with 76mm guns and HVAP ammunition, could now threaten Panthers frontally at combat ranges between 500 and 1,500 meters. This encompassed the vast majority of actual tank engagements. The comfortable standoff advantage German crews had relied upon had effectively vanished. The psychological impact rippled through German tank units faster than official reports could travel. Panther commanders, who had operated with near impunity, now found themselves vulnerable. The tables hadn't completely turned. Panthers still possessed superior armor and guns, but the margin had narrowed enough to make every engagement dangerous rather than assured. Oberleutnant Hartmann's battalion received new tactical guidance on December 24th. Panthers were to avoid exposing themselves at medium ranges against Shermans. They should engage from maximum distance or close rapidly to ranges under 300 meters, where their armor advantage remained decisive. They were to never, under any circumstances, assume they were safe at 1,500 meters. These instructions represented a complete reversal of German doctrine. The Panther had been designed specifically to dominate at medium to long range. Now crews were being told that the very ranges where their vehicle should excel had become dangerous. Some commanders refused to believe it. They'd seen too many Sherman rounds bounce harmlessly off Panther armor. How could a slightly larger gun suddenly change everything? The answer lay in materials science and industrial capacity. Tungsten shortages meant HVAP rounds were constantly in short supply, with priority given to tank destroyer units wargaming. Most Sherman crews carried only a handful of HVAP rounds. Some units never received any, but even limited availability created tactical uncertainty for German forces. Every Sherman became a potential threat because German tankers couldn't know which ones carried the deadly tungsten rounds until they were already under fire. American tank crews, meanwhile, were learning to maximize their advantage. HVAP rounds were too precious to waste on targets standard ammunition could handle. Crews developed strict discipline. Standard AP for Panzer IVs and lighter vehicles. HVAP exclusively for Panthers and Tigers. Gunners learned to identify German tank types at extreme range, saving their tungsten rounds for targets that justified the expenditure. Sergeant Thomas Riley from the 4th Armored Division described the tactical shift in his diary. "We got 6 HVAP rounds per tank in late December. The lieutenant made it clear. These are for Panthers only. If you waste one on a Panzer IV, you'll answer for it personally." We started hunting differently after that. Before, we'd see Panthers and try to survive. Now we'd see Panthers and think about how to get within HVAP range without dying first. The Battle of the Bulge became a testing ground for this new dynamic. German panzer divisions, stretched thin and desperately low on fuel, couldn't maintain the aggressive mobile warfare that suited their equipment. They found themselves fighting defensive actions where American numerical superiority and coordination could overwhelm German technical advantages. And increasingly, when Panthers engaged, Shermans at medium range, the Germans discovered their armor wasn't the absolute protection they'd counted on. On January 3, 1945, near Bastogne, a company of Panthers from the 9th SS Panzer Division attempted to overrun American positions held by elements of the 6th Armored Division. The German attack followed standard doctrine: advance to medium range, engage with superior guns, destroy American armor before closing distance. But this time, the Shermans held position and returned fire with HVAP ammunition. 3 Panthers burned in the first exchange. The German company commander, Hauptsturmführer Otto Kumm, couldn't understand what had happened. His Panthers had been hit frontally at ranges exceeding 1,200 meters, hits that should have been impossible for Sherman guns, yet his tanks were burning. The psychological impact of watching supposedly invincible Panthers destroyed by supposedly inferior Shermans shattered German confidence in that sector. The attack stalled. Surviving Panthers withdrew, not because they'd been outmaneuvered or outgunned in the traditional sense, but because their crews no longer believed their armor would protect them. Fear, once the American tanker's constant companion, had changed sides. German crews began experiencing the same sick dread that had haunted Sherman tankers for months. The knowledge that the next engagement might punch through armor that was supposed to save them. By mid-January 1945, German intelligence had compiled enough captured ammunition and battlefield reports to understand the full scope of American HVAP capability. German Army documents from 1944 specifically discussed the significant effect of new U.S. shells on Panther tanks' Axis History Forum. The reports noted that American tungsten ammunition could penetrate Panther turret mantlets and side armor at ranges the Germans had considered safe. But understanding the problem didn't provide solutions. Germany lacked the tungsten supplies to develop comparable ammunition for its own 75mm tank guns. Even if materials had been available, German industry in early 1945 was collapsing under Allied bombing and resource shortages. There would be no German answer to HVAP. Panther crews would have to adapt tactically to a threat they couldn't counter technologically. The tactical adjustments came too late and meant too little. By February 1945, Allied forces had pushed German armies back across the Rhine. Panther tanks, now critically short of fuel and spare parts, fought increasingly desperate defensive actions. When they encountered Shermans, the encounters were often at close range in urban terrain, where HVAP ammunition was devastatingly effective. Lieutenant Bill Mackenzie's Sherman, the one that had scored those first improbable kills in December, survived the war. His crew fired their last HVAP round in March 1945 against a Panther near Remagen. The hit was clean, center mass on the turret, range approximately 900 meters. The Panther exploded with such violence that Mackenzie's driver swore he felt the shock wave through the tank's armor. After the Panther burned out, Mackenzie ordered his crew to dismount and examine the wreckage. What they found disturbed them more than the combat itself. The German crew hadn't had time to escape. Inside the charred turret, they found the remains of 5 men, one of them barely 18 years old based on his uniform and personal effects. Mackenzie recorded his thoughts that evening. "We destroyed that Panther at a range where they thought they were safe. They probably never believed a Sherman could touch them at that distance. But the kid who died in their turret didn't care about armor penetration tables or tungsten cores. He just wanted to go home, same as us. This weapon we've been given, it's made us deadlier. But it hasn't made this any easier." The human cost of technological advantage revealed itself in ways statistics couldn't capture. HVAP ammunition had leveled the playing field between Sherman and Panther. It gave American crews a fighting chance against opponents who'd held an overwhelming advantage. But it didn't make war less brutal. It simply redistributed who would die. By April 1945, production of HVAP rounds had struggled to meet demand throughout the war, with only 10,000 rounds per month produced by World of Tanks for the 76mm and 3-inch guns combined. This scarcity meant the ammunition's strategic impact remained limited. Individual battles turned on HVAP availability. Individual lives were saved or lost based on whether a Sherman carried those precious tungsten rounds. But the overall course of the war was determined by factors far beyond ammunition technology. Germany's industrial capacity, never adequate to sustain prolonged multi-front warfare, had collapsed completely by spring 1945. After heavy losses in the Battle of the Bulge, General Eisenhower requested that no more 75mm Shermans be sent to Europe. Only 76mm variants were wanted, War Thunder Wiki. The American Army was finally prioritizing anti-armor capability over infantry support, acknowledging that the war had become a battle of armored forces where tank-killing capability mattered most. But by then, German resistance was crumbling not from American technology but from overwhelming material and numerical superiority. For every Panther Germany fielded, the Allies could deploy 10 Shermans, supported by artillery, air power, and logistics that German forces couldn't match. HVAP ammunition made individual Shermans more lethal, but Allied victory came from industrial dominance, not technological parity. In the war's final weeks, Oberleutnant Klaus Hartmann's Panther ran out of fuel near Hanover. His crew abandoned the vehicle intact, joining streams of German soldiers retreating eastward ahead of American and British forces. Hartmann survived the war, eventually settling in West Germany where he worked as a technical translator. In interviews decades later, he spoke about the psychological impact of facing HVAP ammunition. We'd been told Panthers were superior to any Allied tank. For a long time that was true. We could engage Shermans at ranges where they couldn't touch us. Then suddenly, in December 1944, that changed. Sherman started killing Panthers at distances we thought were absolutely safe. It destroyed our confidence. We started second-guessing every engagement. The technological advantage we'd relied on had evaporated, and we didn't have enough Panthers or fuel or ammunition to compensate through numbers. We just kept retreating and dying. The story of HVAP ammunition and its impact on German Panther crews reveals a broader truth about technological warfare. Superior weapons provide advantages only when supported by adequate industrial capacity, logistics, and tactical doctrine. Germany designed the Panther to dominate Allied armor at long range. That design succeeded brilliantly when German crews could exploit their advantages. But American industry responded not by building a better tank, but by developing ammunition that negated German advantages at acceptable cost. The tungsten core of the M93 HVAP round represented American industrial and scientific capability applied to a specific tactical problem. Engineers identified the penetration deficit, determined that velocity and density could solve it, designed ammunition that maximized both factors, and pushed it into production despite material shortages. The solution wasn't perfect. Tungsten scarcity meant limited availability. Performance against highly sloped armor remained problematic. But perfection wasn't necessary. Adequacy was enough. For German tankers, adequacy from their opponents meant catastrophe. Panther crews had operated under the assumption of technological superiority. That assumption shaped their tactics, their confidence, and their will to fight. When American ammunition demonstrated it could defeat Panthers frontally at combat ranges, German crews lost more than material advantage. They lost psychological certainty. And in war, psychological factors often matter more than technical specifications. The 76mm Sherman firing HVAP ammunition never became the Panther's equal in armor or firepower. But it became dangerous enough that Panthers could no longer assume immunity. That shift from dominance to parity proved devastating for German morale at exactly the moment when Germany could least afford psychological defeat. Panther crews who had hunted Shermans with near impunity suddenly found themselves vulnerable, and that vulnerability spread faster than tactical adjustments could compensate. When the war ended in May 1945, surviving German tankers returned home to a destroyed nation. Many carried with them memories of burning Panthers, of friends who died believing their armor would protect them, of a technological advantage that had vanished when American industry finally produced an answer. The HVAP round hadn't won the war. But it had demonstrated that even Germany's best weapons could be countered through American innovation and industrial capacity. Lieutenant Bill Mackenzie returned to Iowa in August 1945. He kept one HVAP shell casing as a souvenir, displaying it on a shelf in his den alongside photographs of his crew. He rarely spoke about the war, but when pressed, he'd acknowledge that those tungsten-cored rounds had saved his life multiple times. Without them, he said simply, I wouldn't have survived December 1944. The Panthers would have killed us all at ranges where we couldn't fight back. The technical specifications of HVAP ammunition, the penetration tables and velocity calculations tell only part of the story. The human dimension, the fear and relief and grim satisfaction of finally possessing a weapon that could strike back, completed the narrative. German tankers couldn't believe 76mm Shermans could punch through Panthers at 2,000 yards because it violated everything they'd been taught about American capability. Their disbelief cost them dearly, measured in burning tanks and shattered confidence. In the end, the M93 HVAP round represented more than tungsten and aluminum shaped into a projectile. It represented American industrial determination to solve tactical problems through engineering rather than accepting limitations. It demonstrated that even significant technological disadvantages could be overcome when industrial capacity and scientific expertise focused on specific challenges. And it proved that in modern war, no advantage remains permanent when facing opponents with resources to develop countermeasures. The Sherman crews who fired those precious tungsten rounds in winter 1944 didn't think about industrial capacity or strategic implications. They thought about survival. They thought about finally possessing ammunition that gave them a fighting chance. They thought about friends who died in earlier battles when standard ammunition bounced harmlessly off Panther armor. And they felt something they hadn't felt in months, hope that they might live through the next engagement. That hope, born from tungsten cores and American engineering, changed how the Battle of the Bulge was fought and how it ended. HVAP ammunition didn't guarantee victory in individual engagements. Panther tanks remained formidable even when facing improved American ammunition. But the psychological shift from helplessness to capability transformed how American tank crews approached combat. They stopped fighting defensively, stopped accepting that Panthers held insurmountable advantage, and started hunting German armor with confidence their weapons could deliver. For German crews, watching that transformation must have been terrifying. The prey had learned to hunt back, the hunted had become hunters, and the comfortable certainty of technological superiority had dissolved into the desperate uncertainty of knowing that every engagement carried mortal risk. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.